Hi, dear students. Today I'm going to continue for lesson 4 and we will study between pages 104 to 106. Today we are going to study about conductivity in liquids. In contrast of last time, which we study about conductivity in solid, which the system was constructed by liquid metal wires and so on. Today, our system is built by a graphic rod, which is called electrode, and they are deep in a solution in a liquid form, and we will see whether a solution is able to transfer or conduct the electricity between the wire or not. Solutions and molten metals like mercury Hg, in temperature of the room they can be they are the form of liquid and they can be tested by this method. Liquids that conduct electricity by movement of the ions are called electrolytes. Okay, if we have a solution or a liquid here, the ions can move through the liquids and we call electrolytes, but some the other liquids that they cannot conduct electricity we call non-electrolytes. Maybe we have like water. The pure water is non-electrolytes. The water cannot make a connection, and also ethanol, petrol, paraffin, and molten sulfur and sugar solution. If you put sugar also, there is no connectivity. They are non electrolytes. But electrolytes like sulfuric acid, they make a connection between electrodes, and there will be electricity through the wire. So why electrolytes can make a connection and electricity conductivity, or why non-electrolyte cannot? This is related to the structure, the binding. This slide. This slide show you if a compound is bonded covalently, it will not conduct electricity because the atoms are fixed in their position. We learned before covalent bonding is sharing the electrons between atoms, and they make a very strong bond, and the atoms just as extra information, they just vibrate, they have a vibration in their position, they are not moving a lot. In another binding like ionic binding, okay, another ionic binding, the negative ions like salt and HCl, negative ion can attract to the positive ion. They can fix with each other, and also they can separate easily in liquid like a water. Example like as an example is salt in a water. The positive and negative ions can be separated in a solution. So non-electrolytes is including, they are including of covalent bonding. Like last slides, these type are, they have a covalent bonding. They cannot be separated. But electrolyte, why they can transfer, why they can make a connection of the electricity, because they can move. They can move in a liquid. So if the compound is made by ionic bonds, it will contact electricity in form of the molten R solution because they can be separated. And here there is an example you can see on the picture. Dissolve NaCl like the salt, they can be separated in a solution, but ethanol, which they have covalent bonding, the atoms in molecule are fixed, they cannot be separated and move through the liquid. When electrolytes conduct electricity, a chemical change happens, which is called electrolysis. Okay, so in a liquid, this one that we are studying, conductivity in liquid, there is a chemical change. The chemical change happen. But if you remember last time when we studied about the solid electrolytes, solid form, conductivity in solid form, uh, there was no any chemical changes. Okay, the electron just moved through the wire, and Cooper didn't change after electricity connection. Here we can compare more. A comparison between the solid and liquid electrolysis. The solid conductivity, which we studied before last time. Today we study about liquid electrolysis. Before we learned that electrons flow, okay, that electrons can move through the wire. A property of elements is effective, like type of elements can be copper or aluminum, which these two are very good elements we can use to form of wire, and it's happened in a solid metal and no chemical change happen also. But as we learned today, in liquid electrolysis, ions can move, not electrons. The positive and negative ions can move, and property of the ionic compounds is effective. Which kind of ionic compound? That they can separate easier in solution. They are better. That ionic compound is better because they can separate faster and they can transfer the ionic ions easier. And these happen in liquids or solution, not solid. If we have a solid structure in the system, it's not happen. And the chemical decomposition happen. We will talk more about this. Movement of the ions. First of all, I need to explain you about the system and liquid electrolysis. This is an example of copper 2 chromate 6, and like if we have this compound in a U shape of the tube. Here the compound copper 2 chromates solution is here in water, right? In water, when they have a reaction, a negative chromate ions is here, okay, CrO42. AQ, that means is dissolved in the water. Okay, this is a negative part of the molecule, and the Cu is a positive part of this molecule, this compound. Here also we have, as we learned before, a negative electrode. We have negative electrode, we call cathode. We have a positive electrode, we called anodes. Okay. In the solution, the positive form, the positive part, which is a Cooper ions, they can move and attracted to the negative electrode, which is cathode, and the positive part of compound, which is chromat, it's a negative form, can be attracted to a positive electrode, which is anode. So when they separate, when these two parts, the negative and the positive, separate and they are solved in the water, they make a different color. Okay, in the compounds, when they are in a form of one molecule, they are green, but when they separate in water, they make a blue color and the yellow color. Okay, so positive ions, Cu, I repeat again, Cu, which is a positive ion of a molecule Cooper 2 chromat, move towards a cathode. Here the cathode is a negative electrode, and these are the positive ions can attracted to a cathode, and the negative ions, which is the chromat 6, they can move towards the anode here, which is positive. So that's why here to the positive ions we call cations, to the negative ions we call anions. Okay, positive ions is called cations, and the negative ions, okay, is called anions. This system which electrolysis carried out is electrolytic cell. Okay, in the whole structure of the solution and the battery we have here and electrodes, all this system is called electrolytic cell. That's all for today, and next time we will talk about the molten electrolysis. And please leave a comment down as your attendance. Thank you so much.